Okay, so this is a little bit confusing. So what we just did was powers, okay? So when I wrote z to the 10, what I meant was take that complex number, whatever it is, 2 plus 3i to the 10th power, okay? This is powers, which means 2 plus 3i times 2 plus 3i 10 times, or however many you want the power of. Okay, so you get that. Now this looks confusing because the next one is roots, and a root is like when you're solving, so in real numbers, if you were solving, say, the equation equals 0. Okay, so now we've got a polynomial equals 0, and we want to solve, we factor it. This isn't powers. We're not writing a bunch of things out and multiplying them that many times. Okay, this is solving for x. Or find the root. Or roots. So in this particular question, can it factor? Yeah. So x equals 4 and x equals minus 1. This has 2 roots. Now x to the 4 minus 1 equals 0. If we're talking in real numbers, we might bring the 1 over and take the 4th root of that, but that's actually not right. Okay? This is what I was talking about on the break, is sometimes you're shown something to make it easier, but it's not actually right. So whenever you do this, do you follow? So this would be plus or minus 1. That gives us 2 roots, but that's not the only 2 roots. When it's a 4th power, it actually has 4 roots, but 2 of them are real and 2 of them are imaginary or complex. Okay, how do you find them if you just do this and that's it, right? You factor it. So everything can factor, it's just sometimes it doesn't have a real root. So this, say, is a difference of squares. Now can you see the 4 roots? This one will give you the plus and minus 1, and this one plus and minus I. This one to the square root of negative 1 is I. So it has 4 roots, and actually every polynomial has the number, the highest power, or if it's a cube, it has 3 roots. They may not all be real, though. So we just ignored that fact in all of math before because you were only dealing in real numbers, so it really didn't matter. Sometimes in pre-calculus they'll add in imaginary numbers and show you how to do that. If you get the square root, like when you do quadratic equation, you might get a square root of a negative number and then you can put I. Yeah, it's another word for solution. Roots, yeah. Okay, so that being said, sometimes it doesn't look like there's more roots if 2 of the roots are the same, and that's called multiplicity, which I hinted at before. For example, if we had to solve this one, it does only have 1, but it's 2 roots. Its multiplicity is 2 because it occurred twice. Okay, so sometimes one root it'll be the same root is what they actually say. So you still have 2 roots, but they're the same. Or you can have 2 distinct roots, or you can have 2 complex roots. Okay? So, in roots, this would be more solving equations. You have to do it in polar form, unless it's easy like this one, but they're not. So you have to do it in polar form. In polar form, we'll actually solve this one first, and we get those 4 roots, so I'll show you how it works. But every other one doesn't work that easy. We can't always just factor it and see what it is, so the polar form will always give you the 4 roots. Let's just go to that one for a second before I do it in polar form. X to the 4 minus 1 equals 0. So we get the roots 1 minus 1, let's call this x1, x2, x3 is I, and x4 is minus I. So there's my 4 roots. Okay? These are 4 different complex numbers. They have an A and a B. So the first one would be 1, and the B would be 0. Minus 1, 0. 0, I, or 0, 1, sorry, and 0, minus 1. Right, if we were to plot those on a complex plane. So 1, 0, minus 1, 0, 0, 1, and here they are. Just going to put a little dotted line between them. Would you believe me that the distance between them is all the same? That they're equally spaced around the complex plane? Every time you find the roots, whether it's 8 roots or 3 roots, they're always equally spaced from each other around like a circle in the complex plane. Okay? I made it into a square, and I'll make 3 into a triangle, but the idea is that they're equally spaced around. So if there was 8, they would be, wherever they appear, they would be equally spaced, and that would look more like a circle. Right? And if you found 10th roots, they would have 10 points, and they would be still equally spaced. So that's how the roots always look. Okay, so here's the formula. So to find roots, and this is, I said it's confusing, but so far you haven't seen the confusing part, but the question will look like this. Z to the n equals a plus bi. Powers will sometimes put z to the n, but it would be like z equals a plus bi, find z to the 10. And that is z to the 10 is a plus bi to the power 10, right? 10. Where this might have a 10 there, but it doesn't have it on the other side. So it's you're solving the 10th root, but you don't just take the 10th root of both sides, okay? So they look so similar, and that's why people don't know which question I'm asking. So one is find the power, so power 10, and one is find the roots, and it usually says, like, nth roots of z. So that's where the other one would be nth power of z. Do you see the difference? This would be the 10th power of z. And this would be the nth root. Okay. You have to be careful on that. So, the formula would be this. So there's the nth root. So you do take the nth root, but then it's cos theta plus 2 pi k all over n plus I sine of the same thing. Okay? So that's how that looks. So k goes 0, 1, 2, all the way up to n minus 1. I'll show you that in a minute. N is the number of roots you want. r is the usual a squared plus b squared, and theta is the usual angle. All right, found in our way that we did polar form. Okay, so this is a subscript, k, so it's saying if you want the third roots, you need to have 3 roots, 3 answers, k0, k1, k2. You stop at the one before the 3. So you start at 0, so you'll write down 3 lines. So, for example, we'll just do that. So find the 4th roots of unity. So, unity is 1. And when they say find the 4th roots of unity, that they are saying, another way to say that question is solve the equation z to the 4 equals 1. So you'll see in every linear algebra book, they say find the cube roots of unity, find the 4th roots of unity, find the 8th roots of unity. They mean of 1. Okay? And they mean just solve this equation. So we just did that actually. That was 1 minus 1 I and minus I, but we're going to do it this way just to show that it's the same thing. So how do we do that? So our complex number, first we need to find r and find theta. We need these 2 things to start. So our complex number is here, nothing to do with z to the 4th, because we're just finding the 4th roots of that. Our complex number is z equals, well, not z, but whatever, 1 plus 0i, right? So I didn't put z because we don't, that's not actually z. So 1 plus 0i, so a 1 plus 0 squared is square root of 1 is 1. Theta. If we plot the point, 1, 0, where does it land? Right here? So 0. We don't go around 2 pi. If it lands right there, it's 0. So theta is 0. Okay. So this will be easy to plug in because it's a 0. So what we're looking for is z to the 0, z to the 1, and z to the 2, and z to the 3, because we want the 4th roots. So we want 4 answers. One of them is going to be a 1, a minus 1, an I, and a minus I. Okay, so we want those 4 answers. And we need to take our formula, which you guys can probably still see on your page. I'll just put it right there. There it is. Okay, so r to the n. What would n be? Right. So n is 4 because we want the 4th roots. R we found was 1, and theta we found was 0. So I'll just write those, and we just fill this in. K is right here, 0, for their first root. So the 4th root of 1, cos theta is 0 plus 2 pi times k. K is right here, 0, over 4. I sine. And the number's the same here, so I don't usually write it over as a formula, I just work it out. So what does this work out to be? 0. So then we could say this number is, the 4th root of 1 is 1, cos of 0 plus I sine 0. Do you agree? Yeah. And if we work this out, what's cos of 0? 1. Sine of 0? 0. So 1 times 1 is 1. That's our first root. We'll get the 4 roots we had. Okay, I'm just going to move these down. So Z1. Same start. This is the same. The thing that changes is the K. So 0 plus 2 pi times 1 over 4. All right, so what does this work out to be? Yeah, 2 pi over 4, which would be pi over 2. Right, so this is 1 times cos of pi over 2 plus I sine of pi over 2. And if we work that out, cos of pi over 2 is 0, plus I times sine of pi over 2 is 1. So this works out to just I. Right, and so you list your 4. So let's list the other 2. Z2, 4 through to 1, cos 0 plus 2 pi times 2 over 4. And this is 2 pi, so that's 4 pi over 4 is just pi. So 1 cos of pi. -1 plus I sine of pi, 0. Whoops. So this will be -1. And the last one will be -I when we work it out. Z3, 4 through to 1, cos 0 plus 2 pi k times 3 over 4. So that's 6 over 4. So 1 cos of 3 pi over 2 plus I sine 3 pi over 2. Cos of 3 pi over 2 is 0 plus I times -1. Oops. There. Okay. Now with 0, that was really easy because you're plugging in 0. But usually the theta is a fraction. So you've got a fraction plus 2 pi, work that out, divide it by 4. It's a little bit trickier to work it out. I usually do it off to the side and then plug it in. So let's do another one of those. Let's say find there. So find all roots of z to the power 3 is equal to, so the key word is roots there rather than the power, -1 plus root 3i. So we need r. So a is -1 and b is root 3. -1 squared plus root 3 squared. 1 plus 3 is 2. Okay, theta. Now this one, when we draw it, it doesn't land on one of the axes, so we need to find it. So -1 plus root 3 would be up here, so we need to find this angle. So how do we do that? Tan of b over a without the sign. So we say, okay, well, where does tan equal root 3? Pi over 3. Pi over 3. So this would be 2 pi over 3, because this all the way to the end is 3 pi over 3. So theta is 2 pi over 3. N would be what? How many roots do we want? 3. So n is 3, and k is going to be 0, 1, 2. We need 3 roots. All right. So our formula, z to the subscript k, is the nth root of r cos theta plus 2 pi k over n plus I sine of the same thing. Okay. So we need Z0. I'm going to write out our 3 roots. So Z0. So R is 2. So we have the third, or the cube root of 2. Because N is 3. Cos 2 pi over 3 plus 2 pi times 0 over 3. So this is 2 pi over 9. Because that's plus 0, so that would be gone. So cos of 2 pi over 9 plus I sine 2 pi over 9. So let's convert these to standard form. So the cube root of 2 times cos of bracket 2 times pi divided by 9. So the first number is 0.965, and sine. Just don't forget to put that cube root of 2 with both of them. 80986. Where am I going to round up here? I'm going to put 4 numbers. Okay, 3 or 4, doesn't matter. So that's our first one. Z1, cube root of 2, cos 2 pi over 3 plus 2 pi times 1 over 3. So what I usually do when I'm solving these is off to the side I would just work this out instead of rewriting all of that. So I would say, so 2 pi over 3 plus, and we want this to be over 3, so it would be 6 pi over 3. So 6, 7, 8 pi over 3, and then we're dividing that by 3, so 8 pi over 9. And if they asked for it in polar form, I would rewrite it but you could just figure this out off to the side and not have to write that twice, right? So if you figure that out each time. Okay, so this one, so 8 pi over 9. I already had the sign in there, so I just changed that. Cos minus 1.184. I have kind of a weird big space there. And the third one, cube root 2 cos, and like I said, you could just figure this out off to the side. So it's 2 pi over 3 plus 2 pi k, k is 3, all over 3. Oh, yeah. Thank you. So 2 pi over 3 plus 6 pi, and we want that. Oh, thank you. Jumping jelly beans. There. 4 pi, so multiply that by 3. 12 pi over 3. So 14 pi over 9. Is that right? Everyone agree before I write it down? 14 pi over 9. And in standard form, .2188 plus minus 1.24i. So I'm not gonna plot these exactly, but our first one was, so not positive, and a positive is up here. So this was to the 0, was somewhere in there. This one would be minus and plus. That's only up about a half, right about here. And our third one was plus, but only a little bit, and minus 1 down here. Right? So if we, you know, do you see that they're sort of equally spaced? Yeah, but equilateral. So, yeah, it will, and it's always equal. So all the sides. So the last one was 4, so it made a square. Yeah. Always. So they're equally spaced around. Yeah. Okay, so that's roots. That's the end of that section. So that's a little tedious, but it's really not hard. The only hard part is that some people confuse the powers with the roots, so you just have to be careful of that. Okay, so what we're going to do next is using complex numbers in matrices and vectors.